Hello. Welcome to Rust Meetup, July. Today,
Hello,
I'll be
everyone.
talking about zero cost abstraction in Rust and iterators. And then at the end, there will be like a live coding session. And this time there will be more interactions. And
Before we start, I would like to introduce the speaker for today. We have Ivan, which is on my right side, and then Xiang, co-organizer for the meetup. So if you are interested in joining us, please do join the Discord channel. If you are otherwise, you are free. Feel free to leave a comment on YouTube streaming. So we will try our best to respond to any questions you have throughout the presentation. So with that, Ivan, are you ready?
okay, welcome to Rust Meetup, July. And today I'll be talking about zero cost abstraction in Rust. And then it will be a lot of most of the parts will be talking about iterators. And today there will be more discussion, more interactions. So you all may need to ask questions in the group, Discord group. And then at the end there will be a live coding session. And just wondering, have you all heard of zero cost abstraction? Yeah, the talk will be about zero cost abstraction, and on the YouTube search, right, I found a few talks related, but the content will be different. Anyone heard of it?
All right.
Anyone have any idea?
Oh.
Okay. Anyone? If you want to say, can just say in the Discord. Okay, maybe. No one. Okay, maybe. Then I'll start. Zero cost abstraction. What is zero cost abstraction? We see this more often the old days. Right now we see this less. And this is you see this in the Rust book. In the introduction, it mentioned this zero cost. It mentioned zero cost abstraction. And also in the old website, it also mentioned the zero cost abstraction here. But the new website doesn't have this. Yeah, the new website you don't see this. They change a lot of stuff. So old website have more of the technical stuff written here.
Can you show
So
us the
the first thing is
website
zero
that you
cost
are referring
abstraction.
to? Sorry? Can you show us the website that you're referring to?
The old one?
No, can you please show the website?
This one? Can you see?
No.
I think I'm streaming. I'm showing the website right now, right? Previous.
No, you are not sharing a screen.
I'm not sharing a screen.
Nope.
I think I'm sharing the screen, right?
No.
No, I can see the screen.
Really?
You can see, right? Just now, do you see the slide?
No. Oh, okay. Right,
Okay,
right.
can you see this?
All right, all right.
Can you see the slide here right now?
All right. Got it.
Yeah, and then this is the, can you see the website now?
Yep.
And this one is the old one. So this one is the book. We call the Rust book. And here it mentioned zero cost abstraction here. And the old one also mentions zero cost abstraction. When first I got into this, okay. So at first I was confused why is zero cost abstraction. Then now I get it. So I'll explain. Or if anyone want to take a guess, what is zero cost abstraction means? Anyone want to guess? Okay, maybe I'll just continue. So abstraction is like a high level concepts. Rust can have high level concepts, but it compiles to low level code. As in, you don't just interface with to do indexing, changing the characters on the original, like using for loop everywhere. Right? So with abstractions, you can write something like high level. High level, you can have an iterator, which is high level. You don't need to write every time. You don't need to do like a for loop. And there's like classes, interfaces, traits that are all considered abstractions. And for example, you see here is you can have web, right? So you can do this. Okay, here's an example. Okay. So now you see the slides, right, Xiang?
Yep.
Okay. And so you see here, you can collect. What this does is it adds the web for each item. This map similar to what you see in JavaScript. And for each item, it adds X by 1, and then it collects it back to a web. Yeah, we'll talk about this later. This is like because we don't know this collect, right, is like there is some types there. So a lot of this abstraction in Rust is built with types. And at first I thought zero cost is like a thing that is like magically make the code faster, because they say zero cost. I didn't know that it is referring to the abstraction that means zero cost, as in like for example, you write some iterators. In other language, it have a cost. Like if you want to do some classes or something, in most languages with in most high level languages, they have cost. Like using sometimes you might hear using for loop is faster than using while loop, right? No, using for loop is faster than using the iterator API, and or something like that. So you need to fall back to the for loop, the low level stuff that it can optimize easily. And then when you use the iterator API, it might be a bit slower. That's what I see. In other comparison, like I think the image. For example, no, I don't think I have example right now, but I've seen what I see in the like other YouTube channels saying that with the similar talks, right? They do a comparison. Like for example, in C# or Java, it's likely that the for loop will be faster than the iterator, and there will be like the iterator will be slower than the for loop. But in Rust, right, the iterator will be faster than, in most cases, it will be faster than what you handwrite. For those that doesn't know what is iterator is just a syntactic sugar for like while I iterator next and then do something with it. It's something like that. And then when you see the cheats, right? So there are a few types of iterator in Rust. So essentially, it's just like syntactic sugar for loop, and then if you see for loop is essentially in Rust, it's just c dot into iter. So it means like, for example, like this. If you have for x in C, so this means wow.
Can you enlarge it a little bit?
Okay.
Thank you.
For example, it will be something like this. Let c equals to c dot into iter, and then wow, let some x it will be this. You see, this will be similar to this. It's essentially just a syntactic sugar to use the iterator, and c.next is the iterator API. Iterator is just, if you don't know what is iterator, iterator is like an abstraction to let you iterate on something, like an array. Yeah, that's why it's an iterator. And then abstractions but zero cost, like how does it do that? Because we thought, like how come like for example, you see in this comparison, right? This is the comparison using for loop, and this comparison using an iterator. And you see that the iterator is faster than the for loop. Like how? So the thing is, usually in iterator, it might be faster than what you can write in for loop if it's a simple one. And even the complicated one, most of the time, it can be faster. It is faster than the for loop using like manually unloop it. You see something like this, iterator. And but like how? So the thing is, the iterator, right, have a lot of types behind it. And abstractions usually have runtime costs in other languages, but in Rust, the abstractions, the iterator performs as fast as the hand roll loop, faster. So the zero cost abstractions essentially means that the runtime cost of the iterator is actually being a compound time cost, in which that the compile time is slow, right? So it means that it is compiled. Is probably one of the reason why a compile time is slow, because of too many abstractions like this. And but yeah, there's like almost no, they don't cost anything during runtime. Like the types will optimize out into like without types, and the enums doesn't cost anything in compile, like in runtime. And how they do it is, okay, I'll show a few types in std-iter. So this is how it works. So the iterator module, right? You can see here there's an iterator module. So the base iterator traits looks like this. Iterator is a trait. A trait is like, if you don't know Rust, a trait is something that defines the behavior of something. It's a bit like abstract interface. It's sort of like abstract interface. It just say like what is the behavior of something. You can add methods for, you can implement a trait for like a struct or an enum. And you in iterator there's a type item. This type is called, what is this type called? And then why there's a type enum. So iterator contains a type here, as in like you see like something like this. Something like this. So there will be item type, and then next, if you call the function next, right, it will mutably take self and then return the next item in the iterator. So basically this like the main iterator. Usually if you just do this, the core, usually you just implement this and it's fine. You don't need to implement other items in iterator. And then there are three forms of iterator. One is iter mute, and into iter. Iter is just iterate over a reference of type t, and iter mute is just iterates over the mutable iterator, mutable reference of type t, and into iter converts the t into iterator, iterate over it. Okay, here it mentioned how to create an iterator yourself. Maybe you look into this. So we have counter structure, which contains a count of u size, unsigned integer, and you implement the methods for the counter and fnu, you create a new counter. Then you implement the trait iterator for counter. So what this does is the counter will contain the iterator over the items size, which is like the counting. And then next is the only required method, right? So you can only just implement next and then you get the iterator. So you can just self count. You increment the count by 1, and then if it's less than 6, you return the self count, and then you get like, if not, you return none. So the option is like option is whether something is there or not. So this is to prevent if you don't know what is the option, it's just like an algebraic data type that lets you cover none. For example, it could be something or it could be none. So you can see it return 1, 2, 3, 4, 5. So this is like roughly how an iterator works. And then there's for loops. And iterator, how it works is like it roughly desugar into this image, and then it will keep looping and get the next value. And this is roughly how it works in iterator. So the thing is, in iterator Rust, you can see that there are many types of struct here, because they are all of them have like, some of them have like specialized function. For example, map is just created from map, the map method. And then some of these structure, right, have implement certain trait. Some of them doesn't implement certain trait. So it's like they can optimize this to a very deep level. They can optimize it. And there are a few of the traits that helps in improving the speed of the iterator and to identify the pattern of the iterator. So there are multiple traits in iterator. For example, double-ended iterator means that you can iterate from the start, or you can iterate from the back. So you can iterate from two ends. Like a whack, you can iterate from the start and from the back as well. But sometimes you can't iterate from both sides. Then there's exact size iterator. Exact size iterator is like you know the size of the iterator, whether it's empty or you get the length. So these are some of the methods that like for example, there are some specializations that, let's say if they have this kind of trait, they will use some specialized function to speed it up. And then there's also like fuse iterator. These are some mechanism. Like once the iterator is fused, it will stop producing value. And so these are some traits, for example. And then speeding up the iterator is usually done by using the iterator size hint. I always go there. Iterator. Okay, let's look at the iterator trait. So you see so it will give you a hint on the lower bound and upper bound of the element of the iterator, like how many items there will be left. So iterator, like all of the iterator, right, they make use of this size hint to do the optimization. And for example, because you can know like how many items is left, then they can directly allocate just enough capacity. They can just allocate once just enough capacity for the whole thing, which is why these are one trick they do. And then there's also trusted land. Trusted land is not here. I don't think it's here. No, it's here. So trusted land is just another trait, but this is a likely trait. So this lets the user know that the length is like size hint, but except that this let users know that you have exactly like that size, exactly that size for the iterator. So you can have that many items. And then there's also in place iterable, another trait, but this is not here. This is internal. Here. This is to let you know that you can directly modify it in place. You can take the internal of the iterator, like iterator. There's like internal buffer, right? You can directly take the original buffer, and you can directly modify that buffer to take the buffer and take it for another iterator, an optimization step. But this is not available for everyone to use. So they only implement this for the internal Rust iterable structs. But most of the time you don't need to do this. Usually it's fast enough if you just use the standard iterator. Yeah, and something new, since Rust 1.50, right? You can use the const generic array indexing. Like you can do 1, 2, 3. This is an array. You see this? This is an array. But you don't need to do this iter. Last time you need to do 1.iter and chain 2. But right now you don't need to do this. It's a lot more. It's a lot more ergonomic. You can just do like 1 chain 2. This what this will do is it will chain iterator of array containing 1 with 2, and then this will produce like you can, if you do next you'll get 1, and you do next again you get 2. And other benefits of iterator includes expressiveness. It's very expressive. You can collect the iterator into multiple types. Like you can collect it into hash set, or you can collect it into hash map. For example, okay, let's see this. Wait, no, can I use hash set? Sorry, wrong. Hash map. Okay, wait, this generic. Yeah, so it needs 2 items. Okay, so it doesn't know the size. Yeah, just put the size. Yeah, there will be some error sometimes. I just fix it. What this does is you just, okay, now you see, now you can get a map from this iterator. See, now you can get a map. Map is like a dictionary in Python, or in Rust they call it hash map. There's also B3 map. So the key is 2, value is 3, key is 1, value is 2. You see, this collect can be collect into this. And also if you use the same collect, right? Let's say you want to collect back to a web. Into iter is just convert the original thing into an iterator, which iterates over the value rather than the reference. It iterates directly over the original value. And collect is just collect into a different struct, but this doesn't work. See, this won't work. It's because there could be multiple.
Why did iter work and why iter doesn't work, but into iter works?
Oh, okay. So iter works over the value, but the into iter works over the reference. Okay, let's see. You mean this, right?
Yep.
So the issue is because it is a reference. You see the item? It is iterating over a reference of a tuple struct containing u size and u size. But iterator is not implemented for this. Okay, let's see the iterator. Okay, for iterator, right, we need to look into the, for the iterator, we need to look into the collect method. So the collect, what this collect does is collect to any item that implements the thread from iterator. So anything that implements from iterator can have the collect method. So I just look into this to see what it implements. And let's look at hash map. You see that there's only one implementation from iterator, which is using the original value. You see this? This is using the original value, but here we are using this. Okay, maybe let's take this. What we need is, because this wasn't implemented, in our case. Yeah.
Yeah, not implemented by what?
Not implemented for hash map. You notice the difference? Because here, right, the type is this. It's a reference. Iterator. Okay, look at iterator. Iterator. Okay, look at back iterator. Hey, how come don't have? It's not original function iter. I don't know why. I don't know why I can't find a back iter. I can't find. So weird. An issue. I can't find. It shouldn't be like this, but never mind. I'll open issue. So, okay, you look into this web. You can see an iter, right? Or is this implemented not for web but for slice? No, it's web. I don't know why it isn't here. Okay, open issue. Okay, so you see that the web here returns an iter of t. So essentially, this is just a reference. I believe this is just a reference. I didn't check. Yeah, you see, it's just a reference. You notice this? The original value is 1, but you get a reference to the 1. Where did this show in reference? You can't see it from this signature. Ah, yeah, okay. You see the iterator? The item for this iterator, right, is a reference of key. So in this case, you see that the wag here, and then with the iter, right, it will convert it into the iter with the
Reference of-
item, it will convert it into iter with the item of t. The t is this. And then the iterator is called when the fn iter. This is the iterator, right? So the iterator for this is item is so the item is this. But what the compiler expected is what is expected is this. So, but this is being expected. But then we got the reference, which means you can't construct it from the original value. Do you get it? And then that's why the error say, so this means the trait is not implemented for the hash map, as you can see here. Yeah, you can see from iterator here, right? Let me write. Okay, so now understand me? Yeah, understand what I'm saying here? You can't construct a hash map using just reference. You need to construct it by using the original value. But I don't know why they didn't implement from iterator with the reference for original hash map. I didn't know why. Maybe there's a reason, but I'm not sure what's the reason. Yeah, I don't know why. Yeah, they will implement extend with reference. But yeah, so I think you understand now, right? Or are you still confused?
Yep.
Xiang?
Yes. Continue.
Okay, let's continue. Okay. So yeah, this doesn't work. You see this doesn't work. Why? Because Rust supports type deletion, but in this case, it doesn't know what type it is going to collect into. You see that from iterator, right? From iterator is like how a struct might be how a structure or an enum will be created from an iterator. So you see that hash map from iterator is implemented for hash map, and from iterator is also implemented for set, for wag. You see, from iterator type T is also implemented for wag. So here, just now we were using from iterator. Let's mostly just white. Okay, zoom. Just now we were using from iterator usize for hash map, right? for hash map usize. You can see it. Hash map. And now we want this from iterator t for vec t. In our case, it is from iterator usize for vec usize. So you see, just one iterator you can collect into multiple types. So here, Rust compiler is confused. What type does it needs to convert into? So I just elide this type. You should know what type is it. Yeah, so now it works. So it's collected into a vec. Vec is like a vector. And so this is the expressiveness for the collect. Italics are readable. Okay, I think, yeah, I increase the size should work right now, I think. Okay, any question on this collect thing? Collect is basically you want to collect an iterator into different type, into another type. So you can collect into multiple different types as long as it implements from iterator. For example, let's say the common one, you can collect into string, you can collect into vector, you can collect into all these different types. Yeah, the most useful one is you can use the same collect for hash map and hash set. Hash set is just basically set, and hash map is just map. Any question on this? So this is the expressiveness. But yeah, there are too many types behind the scene. So sometimes you might get confused a bit. And any question on this? Expressiveness? Like how it is able to collect into different types. If I go too fast, maybe you want to slow me down. Yeah, any question on this? Like collecting into different types. Like you have an iterator. What it does is you have an iterator, this one. You have an iterator. And you want to collect this iterator into another type. Yeah. So if there's a question, just ask. Any question? Okay, so this is the collect, how it works. So there are multiple threads behind. There is into iterator, from iterator, and the collect uses both of them. Then, okay, now let's look into auto vectorization. In a lot of time, right? Rust auto vectorize the code, as in auto vectorization means that you use SIMD, which stands for single instruction, multiple data. Yeah, single instruction, multiple data. So it uses one CPU instruction, but it processes like multiple data, like four times the data or 8 times the data. Then what this does is it will automatically use the faster function. Like it will automatically iterate over the four item together. It will go through 8 item in one shot rather than going through one by one. So like it's a free optimization. But sometimes you need to tweak it a bit, the iterator, tweak it a bit, but it's not always the case. So only sometimes you might be able to make use of SIMD. But if it makes use of SIMD, it will be a lot faster. Okay, and then these are mostly because due to the types in place, the types other like for example, yeah, the types they have in place, and a lot it depends a lot on the compiler. But if you still want to manually vectorize, manually write SIMD code, you might want to like use the SIMD, which is a lot harder to write. The code is a lot more troublesome to write. Example, an example. No, not like this. Not like this either. Maybe this is a very high level one, but yeah, not like this. Something like here's an example of SIMD. I think maybe they improve it a lot already. Yeah, something like this. You see like set 1 EPI 8. Yeah, you need to manually write this to get the feature. And yeah, this is about auto vectorization. So a lot of time you get the free performance from Rust. Then later you can also easily switch to Rayon to parallelize stuff. So for example, let's look at a quick. So usually you have an iterator. Don't see this. Originally it was iter, right? Then they have a map, you have a sum. But you want to parallelize it, it's just like you just add PAR underscore, then it will automatically change that to use all your CPU cores. Now you just add like these 4 characters, then it will change the whole iterator to use all of your CPU cores, which is very easy. Yeah, just one step. So when you are already using iterator, if you want to convert your application to use like all of the cores, right? You can structure it in an iterator format. It doesn't cover all the cases, but a lot of the cases you can just PAR underscore add this, then you can make use of the parallelism that your computer already have. Yeah, this Rayon. But yeah, it's only useful for CPU bound tasks where you need a lot of CPU. Okay, now any questions here about Rayon or auto vectorization? Is there any question on that? Yeah, any question? If no, then I'll continue. So next, there will be guns. Like last time I faced when using the iterator API. Pickable, if you use Pickable, which is like Pickable is like this. You can pick the next value in the iterator. You can like you can look at the next value without taking the item. If you next right, the iterator you go one item next, go one item forward. But pick allows you to look into the next item without taking it out. So there's a difference. So if you use Pickable and you use sref, wait, no, not sref, by ref, iterator. So you borrow an iterator, then you have multiple iterator there, and you use together with pickable, and you use this tick or something. Then sometimes you might take something. Sometimes you might pick something, and sometimes you didn't take something, which will make you confused. So try not to merge these two together. And yeah, but other case I don't see any issue. If you don't use pickable, it will be very safe most of the time. I don't know why. Yeah. But it's not. Oh, piles. It's not pile serializer. But yeah, so there are quite a lot of iterators. I'll just look through a few. First, last iterator you can have all of these if you just implement the next method in iterator. You just implement this one required method, then you get all of this for free. You have like first, last, nth, find, position. First give you the first item, last give you the last item, nth give you the nth item, find, for example, will find you the item based on the predicate. Like for example, you want to find like something that matches this, like find equals to 2, yeah, matches this 2. Find 5, you cannot find anything. Position is like find. Besides find, rather than giving you the original item, it gives you the position of the item. Yeah, it's just giving you the position of the item. And you have step by max, mean step by is like just skip certain step. No, step by is you go through like every nth step. Like for example, you want to step by 2, it will be 0, 2, 4. It will go 2 steps. And the max is just get the max item in the iterator, mean get the minimum item in the iterator. Zip, you can zip multiple iterator together. You can zip another iterator, so you get 2 items in one shot. So there's zip. And enumerate. Enumerate is like the Python enumerate. It will give you the number at the side. But you see, it doesn't take any method. Okay, let's show. Enumerate. Okay, let's say I have to 1, 2, 3. You enumerate it, and then it should have like you print n and x. So now you see 0. The first time will be 0, 1. Oh, you need a type. Yeah, so this will be the type, and this will be the length. Okay, it doesn't allow you to use the length. Oh. I think I need to do this. Let's do this thing. Variable enumerate. Yeah, so you get 0, 1, 1, 2, 2, 3. But what if you want to start from you want to enumerate from the item 1? You want to start from 1 rather than start from 0, enumerate. Like people new to Rust may be confused here, because enumerates you can't like set the start value. What you do instead is you just use. Just now we learned that there's zip. Just use zip.
Before that, I think you may want to explain why an array is not an iterator. You cannot do a enumerate call directly on the array.
I think you can. I don't know why cannot. I think you should be able to do, right? I think it should
Probably
work.
no, not this one. The previous step.
Okay, that didn't let me figure out. Okay. Okay, so it works. Maybe I explain this first. So this is a range pattern in Rust. Essentially means it starts from the number 1 to don't know what number to ad infinitum forever. So it's Z with V. So it will be 1, 2, 3. So this like it's just like this will be similar to like enumerate, but usually we just use enumerate. Okay, back to that. Why this doesn't work? Let me look into this. Okay, this is because iterator is not implemented for the iterator is not implemented for the array yet, the original value. But iterator is implemented for this. So let's look at this iterator.
You probably want to explain what do you mean by those things.
What do you mean those things? Huh? No,
You need
I
to
don't know
explain what. Go back to the compiler error.
Hmm?
Yeah, what's the square bracket integer?
Oh, okay.
Yep.
So this thing means array. This means also array, but it doesn't show the length. This is a mutable reference, which means a reference and mutable. Yeah, this one can be another talk, but it's just like a mutable. It's like a mutable pointer, but it's like a mutable reference to an array. But this one is to a slide. No, this is to a slice, but this is to an array of 3 items. But iterator is, I don't think iterator is implemented for this, which is why you get this error. Yeah, because iterator is not implemented for this. So I think maybe later they'll add it to Rust, because the iterator, this one is very recent. They just add a lot of the iterator. This one they call the const generic. I think it's const generic or something. So this array with the number is here. Yeah, they added this quite recent. So maybe not every item is implemented, which is why you get this error. Yeah, and then if you do, iter means that it will directly make it into a reference, which will work. I think this might work. I see that it didn't work. Don't know why. Yeah, this also didn't work. I don't know why. I don't know why. But yeah, this have the same issue because this is here. So you want to hide this. So the iter converts it into the something that is iterable. Let's look at array. Because there's array, right? Yeah, I don't see that. So that's why you can't directly use this for enumerate, which is one of the reason why. Yeah, I don't think I can explain that at this point of time. See? Maybe I'll continue. Is there any other question? To enumerate? Yeah, which is why you need to look into the types, and which is why you need this iter to convert it into an iterator. And then there's all this map, filter, filter map, fold, keep while, take while, skip. Map is just for each item, you do a function and then give some output, like just now I show. Which we just like multiply by 2. For each item, do something and return the output. Filter is just filter item. Like you want to filter positive, so you filter all the items. Like if you get the next value, it will skip all the items that is not true here. That's filter. And then filter map. Filter map is like both filter and map. This is also used quite often. Like let's say you need something that is returning option. You see this signature? So the function is like a filter, but it's like a map. If it's none means it will skip. Like for example, if it is none, you can pass 1, so you get 1. You pass return a result. Okay, convert the result into option. Result is like option, but it have okay and error type. But I won't explain a lot of that here. It's like option, but it's not option. And okay, just convert okay, the result of okay to some value and error to none. I basically just convert this. If it can pass this into integer, it will return the integer. If it cannot pass, it will return none. That's why you see 1 and 5. All these are invalid. So there's filter map. It's quite useful. Fold is like reduce, but it's not reduce. So fold you can give the first value. Then it's like for you have an accumulator, and for each of the value you pass through, you can use the accumulator and do something with the value. In this case, it's doing a sum here. Your initial value of 0, accumulator and accumulator x. If you are familiar with the JavaScript, or if you are familiar with JavaScript reduce, I think have, right? Python also have like a Python have the iterators have reduce as well. You might see this pattern, or if you are from functional language, you might see this pattern. So this basically just fold it. It's like doing a sum here. And there's also a try alternative which can fail. And fold and reduce. Yeah, both. Reduce is new. Reduce is similar to fold. I think it's similar to fold, except it takes the old value. It's like fold first. I think reduce is like fold first. The first value as the accumulator. Reduce. That's the difference. And then there's pickable. We showed pickable just now is to pick to the next value. Flatten is like, let's say if you have array of array, you see two array, you flatten it into single array. Just flatten. You have inspect and by ref. Inspect lets you let you do something that you can print the value for debugging. It's very useful for debugging. Like inspect a value. And this is very useful. I think this feature is very useful for debugging. And then you have like by ref. Just like I explained by ref, you can, let's say you use the iterator. Use the iterator here, but you want to use it a second time. So it's like it's something that you duplicate the iterator or something. You can use both. And then there's partition and windows. These are very both high level function. Partition is like partition is like you split an iterator into two partition. Like in this example is you split a single iterator into an odd and even. I think this is very rare. Even in other languages, I see this very rare. But sometimes I think it's quite useful. You split this into odd and even, split it into two groups. And then you have windows. I think it isn't here. No. Why it isn't here? I think maybe slides only have this. You have like windows, as in like first two value. If you have windows 2 means second two value is windows, and you have chunks. Chunks is like if you 2 means two value and two value. Yeah, this is chunk. And then it's chunk exact. So you see there are a lot of methods on the iterator. I think technically just now the tool is not iterator, but it's similar to the functions provided by iterator. And collect, we mentioned about collect just now, the mechanism. Is it uses from iterator and into iterator to collect into any type you want. There's all and any. All and any is quite common. It's just if all of the items fulfill the requirement, then it will return true. Yeah, it's just like that. And if all means if one of them is false, right? Then the iterator will stop. And then it will directly return false. It's like a short circuit and directly return false. Same for any. Any means if any of the items return true, then it will return true. Otherwise, it will go through all the items to find. If it goes through all the items and cannot find anything, it will return false. So there's all and any, quite useful. I think it's quite common. Even in other languages, it's quite common for all and any. And you have some product cycle, some you just sum it. Yeah, basically you just sum the iterator. Add them together. It uses the sum trait also. So if you have anything that implements the sum trait, you can add them together. Product is just multiply them. And cycle is you can just like loop again. These are like, you see, there are quite a lot of functions, and you have skip while, take while. There are quite a lot of functions over here. So this is like quite huge. And if you use them, if you know them, like sometimes you can even max by something. So there are quite a lot of functions here. And if you know them, then you can keep the code very short and concise, but you might spend some time reading through them, understanding like what do what. Yeah, any question on this? I think I go through quite a few of them, which I commonly use. I think I use quite a lot. I use a lot of them frequently, different ones. Yeah, it's quite common, the one I mentioned. At least I use them quite frequent. So usually I don't. So like when there's a case, I use both. Imperator loop is like for loop, and I use both. I use the iterator as well. So I think which method is more readable, I'll use that method. more readable and more understandable. So in some places, I can't use iterator because I need to collect multiple items, multiple aggregation. In those cases, I can't use iterator, so I'll fall back to use more normal loops. But in usual case, I'll just use an iterator, which is quite useful. Can simplify the code a lot, made it quite short. And yeah, you see that it's very high level. You get all this pattern, very high level. But all this in runtime, they don't cost stuff. Like, so it's related to the zero cost abstraction, as in everything is types during compile time. And it will be compiled into the so the runtime, all these types are gone. In runtime, you don't get the types unless you do unless you do reflection or something. But yeah, you don't get the types in runtime. That's why there's no cost. You can use as much as possible. But if you use too much of these types, sometimes like the types might be hard to debug the compile time error. The types are like so long, and you don't know which part have error. But if you are used to it, then you can easily pinpoint where is the error during compile time. And yeah, live code. Okay, live code. An example. What should I do? Live code. What example is this iterate? Okay, let's look into implementing, what is that called? 1, 2, 1, 1, 2, 3, 5. What is that called?
A Fibonacci sequence.
Yeah, Fibonacci sequence. Okay, let's do that. Okay, so Fibonacci sequence take the last two numbers. We'll build an iterator using with Fibonacci sequence. So Fibonacci sequence you have the first is U size and the second also U size. So I create a new value. Usually I will just do default, but yeah, I just create a new value. Should start from 1, 1. So now we implement iterator for Fibonacci sequence. Okay, first let's create a new Fibonacci sequence. This method create a new structure. X is 0, 1, and Y is 1. First value is 1, 1. I think we can start from 0. Lazy to type this, let's derive. So what this does is it will generate a code for Fibonacci, which is 0, 0. Start from 0. Implement iterator for Fibonacci. The type item, just now you see iterator, right? You need to implement the type and item. And you need to implement the next method, which takes a mutable self to return an option of the self item. So the item will be U size. And I'll have the next method, create a function, next method that takes in self mutably and return an option of self item. Okay, so Fibonacci is you add the two numbers together and then you move them one number backwards. So first I'll extract the x and y value out. Can you do that? Okay, let's do a to-do. Create a new Fibonacci type instance. And next, just get the next value a few times. See if it compiles. Oh, so it says that if you want to iterate the next value, because the next, right? The next takes a mutable self. You can't just next without being mutable. So Fibonacci needs to be mutable, as in it needs to be unique, and other items can change it. So next can take the next, can change the next value. It will iterate over Fibonacci and change the next value, which is why you need this. Okay, so it works. Now you have the x and y value. Next is you match. Just do mesh. Okay, let's say Fibonacci x, y. Let's say if two number is 0. If 0 means so I want to return two items. I want to first return the value v, and so this will be, so the value will be 1, and then I'll make it like 0, 1. And if Fibonacci, I will special case the first two option, because like the first two option will just special case it, and the second, because the first two value is also 1. I'll just return these two special case, and for the others, x given the x, y, because the y is the next value and the x is the second O value. I don't know what is this. Supposedly a y, I think I got it reversed, but never mind. So the Fibonacci for this is x plus y, right? X plus y. And then the Fibonacci is, for example, x. No, this is x. X is y, and then y is x plus y. Like this, right? So what you do is you set the self value to fit, and then you return v, return value v. Let's see if this works. I don't think this works. Yeah. Yeah, because this is this is the structure, so you need to specify the value. You need to specify the name here. Unless this is x, unless this is x, you can elide. Yeah, I forgot. I don't think this works either. Oh. I think I should just remove the XY. I don't know why I did this. Okay. And cannot add these together. I think we need to do this. Yeah, so we need to dereference this to get the, or we to assign it back to the original value rather than the reference. So the other error is because it needs to return option, so you need to return a sum because it has some value. Okay, so you see the first value is 1, second value is 2, third value is 1, 1, 2. Okay, so it works. But right now, we just want to get like 10 values. And we want to enumerate it as well. So we will enumerate Fibonacci. Enumerate Fibonacci and the value. So we want to print the value. And V. So print, for those that not familiar with Rust, this is a macro. Yeah, so you get 1, 1, 2, 3, 5, 8. Oh, wait, there's too many. Yeah, we didn't limit it. So we want to limit it to 10 values. I think we did too much. We just want the first 10 values. You notice just now we have take, right? Yeah, we just take the 10 values. Yeah, so we just take 1, 1. Okay. Yeah, see, just like this with the iterator. But of course, the more correct version, I don't think my version is very correct here. Supposedly, you can just do just the x and y doesn't make sense. Just do the xy here. You can just change it to x and y. Basically, you can just replace this with x. I think this will be simple because the order matters here. This way will be clearer. Oh wait, it's missing. Yeah, the type is wrong. Should be type. Yeah, see, this is clearer. I think we could make it clearer by doing this. Wait, can't. Yeah, then I think it's this. Yeah, so is there any question on this? So this is how you write a Fibonacci. And yeah, now you don't need mutable here because you don't run the next value. Just do enumerate. And enumerate takes self, it takes the original structure, the whole ownership of the original structure, and then enumerate it. That's why you don't need the mute. And yeah, this is output. This is like sort of implementing your own iterator for like custom type. You just take the value, add them together, set the next type. Is there any question on this?
Also, it's worth mentioning that enumerate itself is also implementing iterator. That's why you can
Yeah.
there.
Yeah, enumerate implements iterator. Yeah, you see the item is field size and the original item. Yeah, thank you. Is there other question?
Oh, and please stop switching to your chat app, please.
Is there other question?
No, not for now.
Or maybe someone wants to give an other example. Someone wants another example. Okay, this is implementing your own iterator. What else?
I guess we do another simple one, then we close the stream because it's kind of late already. It's almost 9:30.
Okay, do a simple one. Let's say you want to sum even number. You want to sum even number up to 100. You think that's okay?
Sure, do it.
Or sum the first, or you want to sum the first 100 even number. Okay, let's do that.
Do it.
Sum the first 100 even number. So you will start from 1. So you have a range. And you want to filter out the even number. So it should be able to modulo by 2 equals 0. It should be even. This means it's even. There's no remainder after being divided by 2. And you want to sum the first 200. So no, 100, 200. I don't remember, but never mind. Just is 100. Just sum. Okay. Yeah, done. Wait, no. Done. Give a type. Yeah, this is another method. You can just put a type here for integer. Anyway, I need a type here. Yeah, I think the sum needs a type. No, I just give it a type. Okay, 10100. Is that correct? 2 plus 200 multiplied by
50. Correct?
50.
2
2
plus 50.
plus 200 multiplied by 202 multiplied by 50. Yeah,
Yes.
correct. So it's 10100. Great. So that is the algebraic progression. Just take the first number is 2 and the last the 100 the number 102 is 200, right? It's just 2 plus 200 multiplied by 50, so 10100. Yeah, yeah, this is correct. So just like this. And is this too simple or what? It's too simple. Or is there any other example? Any other question?
Please don't keep
Okay.
switching to the,
The C question. Any other question?
it's almost 9:30. Does anyone have any questions to ask to
Any
our
other
speaker
question?
of the day? If not, we are closing the stream soon. And if you want to talk to Ivan, please join our Discord. The link is in the description of the video. I don't see any questions. So I
Yeah,
guess
so mainly a
that's
lot
it
of this is
for
due to the types. You see all of these types.
you. So I guess that's it for today.
Okay.
We'll see you in September.
I'll see you in
Thanks,
September.
Ivan, for the presentation, and thanks everyone for watching. We'll see you again in September.
Bye-bye.
Do join us on Telegram and Discord if you want to stay updated to our events. That's it. Thanks, everyone. Bye bye.
Bye-bye.